Welcome everyone to lecture 10, on which we're going to talk about local and global winds. We'll be looking at the different type of winds that we can observe on the planet by looking at the different type of scale, how winds is being created. We'll be kind of summarizing the different type of local skills before going more like globally, looking at how wind circulation happen over the planets, and finally talking about more major type of wind system, such as, for example, the ENSO, the El Nino system that is happening here along the Pacific side. But before that, I have a question. What do you call a bald man on a windy day? Well, this man is fortunate. Okay, I'm just keeping the joke, and let's go over the concept of wind, and in particular looking at wind based on scale. We have, in fact, different type of wind based on the scale you're looking at. Time-wise, like the length of the duration of the wind, and on the distance region, the space-wise of the wind, how big the wind will be. And so we can make a classification of the wind based on small winds that will be what we call microscale, winds that are about a couple of meters big, that will last usually for seconds to minutes only. Then we do have mesoscale wind that will happen over regions between meters to kilometers, and those winds will last for minutes to hours, such as we can see, thunderstorm, tornadoes, water sprouts, or dust devils, for example. We have the macro scale that will be, in fact, covering over thousands of kilometers at this point. And the macro scale can be divided into two, what we call the synoptic scale and the global scale, with the difference between global really covering the Earth. Meanwhile, macro scale will be covering continents such as hurricanes, tropical storm, or the low pressure system, high pressure system, the weather fronts. So mostly the goal of today is to be kind of speaking about all of that, and we will kind of follow the path of going from small to big. And to start with, we're gonna talk about the micro scale and wind that tend to happen over a very short time period, mostly created by a local turbulence. And this turbulence create what we call eddies. Eddies usually tend to refer mostly to the fluid, and it's really used a lot in for people studying ocean, for example, and the motion of water. But we can also use it, since the air is a fluid, we can also use it in weather. And so eddy is, in fact, a whirl of air, a motion, a circular motion of air that happens when the air goes above an obstacle. As soon as we create the air goes above an obstacle, in fact, it's creating this whirl. As we can see right here, the wind's blowing above the house, and locally, we have just on the behind of the house a small eddies being created. And it happened that this small eddy, this little whirl of the wind, may impact on the wind that is just above, creating a strong potential wind gust just behind the obstacle. And so these tend to happen mostly micro scale, but sometimes we can also observe it in macro scale, bigger scale, when, for example, we look at the wind going over a hill or the wind going over a mountain. It will also flow, and on the leeward side, when the wind is going down, we can observe those eddies being created. And as a consequence of that eddy happening, we kind of create some oscillation with some potential rotor system that will be following and creating this disturbance. So this is something that is observed in small scale and also in the large scale, creating, in fact, the motion of this air. Why am I speaking to you about that? Because here in California, we are used to see what we call the dust devil, and this is, in fact, a consequence of these eddies. Most of these dust devils that we can observe looking like a small tornadoes, but it's not as dangerous as the tornadoes. The wind speed is quite less, the size is smaller. It can be just a couple of meters of diameters, and it's very short-lived, maybe a couple of minutes. A lot of time, the way it happens is the wind will blow over a hot surface first, and it might be having some obstacles, and it can be trees, it can be rocks, it can be anything. And on the other side of the obstacles, we will create these eddies like that. Okay, oops, maybe let me do. So this kind of circulation, but because it's a hot surface, it has to happen usually in hot weather. It's happening usually in hot weather. You tend to have some convection happening because, well, this is a warm surface, and so you do have a combination of both the rising up of the air just because it's warm, a convection, and the eddies, and you creating this column of air that is in fact going toward the sky, which is in fact what we call the dust devil, rising up the wind. And this is something that is quite common in California that we observe during summertime, and I have a little video to show you right here about this dust devil.
It came out of left field, literally. A dust devil delayed this college softball game for a short time. So how do they form? Normally, under clear, calm conditions, the sun can heat up one part of the ground faster than others. Air begins to rise over this hot spot, pressure's lower, and nearby air begins to spiral in. This column stretches upward, intensifying the spinning motion. Winds increase and swirl around the low pressure. The swirling air can pick up dust and dirt, giving you a dust devil. They can stretch from 10 feet to over 100 feet wide, and the winds can exceed 80 miles per hour. Occasionally, dust devils can get strong enough, in that EF0, EF1 on the enhanced Fujita scale, to cause minor damage. They can rotate clockwise or counterclockwise and also appear in groups. Dust devils are cool to look at and less destructive than tornadoes, and they've even been spotted on Mars.
All right. Another type of wind that would be at bigger scale, at mesoscale, would be in fact an orographic wind, which also can include the eddies, since the wind will go over the mountain, and as it's going down the leeward side, you may observe eddies, but the wind in itself that goes down the leeward side has a specific name called the Chinook wind, or in Europe they call it Föhn wind. And so we talked a lot about that orographic lifting already, since we talked about condensation, the fact that the air was losing its humidity, coming down the leeward side, drier and warmer. But we didn't speak about the wind. The Chinook wind or Föhn wind is in fact the wind that comes down the slope on the leeward side, and it's coming warmer, drier. Remember that because you're going down in elevation, the pressure increase, and so the temperature start to increase, and usually bringing drier conditions tend to be drying up the vegetation and leads to desertification on the other side, which is something we observe on the other side of the Sierra Nevada toward the Owens Valley, and also in the Rockies, bringing this hot and drier to the high plains. So it's also very specific. The Chinook wind is specific of high chain mountain when the wind has to cross over. Then I'll take a break on the video and invite you to join me on video number 2, because we'll talk about a group of winds with several examples. We'll talk about thermal circulation winds, and on this one there will be several examples of these thermal circulation winds, and I will just focus on that for our next video. All right, so see you just in a bit.